Right. So today we will discuss relative velocity related problem. Right. So now here basically this is the problem. Right. A combat ship travels along north at a velocity of 20 kilometers per hour, and then the radar system of the combat ship identifies that one opposition boat. Right. Be very careful. One opposition boat. Right. Is approaching the combat ship at 10 kilometers away from south, right? So while this combat ship is traveling, right, the radar system of the combat ship, right, that safety system, right, that identifies that there is a kind of an enemy's boat, right, or opposition's boat is approaching the combat ship at 10 kilometers away from south side, okay, right. So then after couple of hours, so be very careful about this period. After couple of hours, right, the radar system warns the opposition boat is now 10 route 3 kilometers away from east, right. That means after a time duration of couple of hours, right, so the safety system, the radar system of the combat ship, right, that detects that the current position of the opposition boat is 10 route 3 kilometers away from east direction, right? The direction is east, right? Right. So now I will explain you the diagram, right? So now see, when you are going to consider the first scenario, right? So the combat ship is traveling along north, right? Because why north? Because it is said north, right? Combat ship travels along north at a velocity of 20. It is said, right? Now here combat ship travels along north at a velocity of 20 kilometers per hour. That means that velocity is relative to Earth, right? So let's say, okay, so let's use some notations are there, right? So I will use the letter C to denote the combat ship, and the letter OP to denote the opposition boat, right? The letter E to denote Earth, right? So now in this problem it is said that the velocity of the combat ship relative to Earth is 20 kilometers per hour towards north direction, right? So I hope that is clear. Now carefully focus. Now let's say now the time duration is like couple of hours, right? So for our betterment, right, we will consider some particular time for that. Okay, let's say 1 p.m. time. So what's the time now? Now the time is 1 p.m., right? So the combat ship is here. It is traveling at 20 kilometers per hour towards north. At this particular moment, the radar system identifies 10 kilometers behind this, right? There is a enemy's boat, right, that is detected 10 kilometers behind the combat ship. The reason behind, that means 10 kilometers away from south. That means if you consider this position as the reference, right, if you consider the position of the combat boat, or if you consider the position of the combat ship as the reference, right, south means below, right? South means below, right? So 10 kilometers below. Below means south, right? Okay. So that is okay, right? So this I have used to indicate the opposition boat, right? So now after couple of hours, right? Couple of hours means, let's say, that means now, what is the time now? Now the time is 3 p.m., right? Right. So now the combat ship is traveling along north with respect to Earth, right? There is no issue related with it, right? Because what is this 20 kilometers per hour? That is the traveling velocity of the combat ship relative to Earth, right? Velocity of the combat ship relative to Earth is 20 kilometers per hour towards north, right? No issue with it. But now the radar system of the combat ship detects now the enemy's ship or the opposition boat is 10 root 3 kilometer of a distance towards the east side, right? So that means at 3 p.m. the radar system detects that the opposition board is 10 root 3 kilometers away, where the opposition board is positioned at east, right, towards east, right? So now this is the distance, right, 10 root 3 kilometers towards east, right? So now there's a very important thing that I need to mention, right? So now at first it is said that the opposition board is 10 kilometers from the south side. So now it is said that after a couple of hours the opposition boat is 10 root 3 kilometers from the east side. So now what is that south and east issue, right? So that means just think that there is a person who is inside the combat ship, right? So this south and east scenario is something that it is undergone by a person who is inside the combat ship, right? Okay, like for a person who is inside the combat ship feels that, or for a person who is inside the combat ship sees that at 1 p.m. the opposition boat is here, at 3 p.m. the opposition boat is here, right? Actually that is not something that is undergone with respect to earth, right? Okay, so these two scenarios are seen by someone who is inside the combat ship, right? At 1 p.m. It is here, at 3 p.m. it is there, right? Okay, so now the most important thing, I will consider the position of the combat ship like a dot here, this dot, right? Okay, so now at 1 p.m. this is the distance, right? If this is the combat ship 10 kilometers behind, that means if this is north, this must be south, right? So what is this distance? 10 kilometers, okay, right? So this is happening at 1 p.m. okay, right? So now after a couple of hours, that means at 3 p.m., right? Now the current distance between the combat ship and the opposition boat is 10 root 3 kilometers. Now this is east, right? Okay. So now if I join these 2 points, right, here you can see a path, right? So what is this path? This path, this is the path, carefully focus, of the opposition boat, path of the opposition boat relative to combat ship, right? So this is the path of the opposition boat relative to the combat ship, right? So then what is this distance? You know, this is right angle there. So what is this distance? This distance is square root 10 root 3 whole thing squared plus 10 whole thing squared, right? So let's find that here, this distance. So let's call this as x, right? So what is x? Square root 10 root 3. What is 10 root 3? If you square that, 10, okay, I will write like that, whole thing squared plus 10 whole thing squared. 10 root 3 whole thing squared, so that is 100 into 3, 300. 10 squared is 100, so it is 400 there. Square root of 400 is 20, right? So now you know this distance is 20 now. Now that 20 kilometer distance is achieved within couple of hours, that means within 2 hours. So divide this by 2, 2h, 2 hours. So what is that velocity? 10 kilometers per hour, right? 10 kilometers per hour. So what is that 10 kilometers per hour scenario? That is the velocity of the opposition boat. Velocity of the opposition boat with respect to combat ship equals 10 kilometers per hour, right? Okay, so that part is okay, right? Okay, so now focus, there is another important thing, right? So the velocity of the opposition boat with respect to the combat ship is 10 kilometers per hour, but that's not the final answer, right? There is one more thing that you have to add, right? So what is that? So here it's not only about the velocity, you have to focus about the position also, right? Position means this angle. See, here you can observe some angle alpha, right? You see that, okay? Because this is traveling with respect to this angle, right? So you have to give some sort of consideration to this angle, right? So then what will be our angle alpha? If this is the angle alpha, right? So then you can form another relationship. So let me write that here. So that means tan alpha equals, right? Tan alpha equals 10 root 3 divided by 10, right? So then what is tan alpha? Root 3, right? So then alpha is tan inverse root 3, okay? What is alpha? Alpha is tan inverse root 3. Actually, what is it? What is tan inverse root 3? That is nothing but tan inverse root 3 is 60 degrees, right? So now you have to define this particular angle, right? So 60 degrees, measuring 60 degrees from north, right? So there is a particular way that how you should tell that. That means, now see, here it is 60 degrees. That means 60 degrees measured from north. Now see, this is measured with respect to north, right? That means upward vertical. This angle is measured from the upward vertical, upward, because this is a downward vertical, right? So 60 degrees measured from north towards east, towards east. So what is the angle? 60 degrees measured from north towards east, towards the east direction. So that means you have to give the perfect answer, right? Velocity and as well as the angle, right? Okay, right. Okay, so now the last part is that we have to calculate the velocity of the opposition boat with respect to earth, right? That means the actual velocity of the opposition boat, right? So how we denote that? We need to calculate velocity of the opposition boat, OP, with respect to earth, right? So that is the target, right? So for that we are going to use a formula, right? Because basically there is a formula called let's say velocity of A relative to B, right? So that equals velocity of A relative to C plus velocity of C relative to B, right? That's the general formula, okay? VAB equals VAC plus CV, right? So that kind of a formula we are going to use here, right? So that means velocity of the opposition boat with respect to earth equals velocity of the opposition boat. Now we need to consider some another third element, right? Some third party thing, right? So velocity of the opposition boat with respect to earth equals velocity of the opposition boat with respect to combat ship plus velocity of combat ship with respect to earth, right? So now you can see that relationship, right? Just look at here. Velocity of A relative to B equals velocity of A relative to C plus velocity of C relative to B. See, that pattern is there. Opposition boat, earth, right? See, opposition boat, right? earth, right? So now what is that third element? Third element is C. Here C, that means in the actual scenario here it is the combat ship, right? So now we know that, right? So we know the formula, right? So now we know the velocity of the combat ship with respect to earth. We know that, right? So that is 20 kilometers per hour, right? That is 20 kilometers per hour, and also be very careful about the angle, right? The position, 20 kilometers per hour towards north, right? North. But now if you consider this one, what is the velocity of the opposition boat with respect to the combat ship? You know that, right? It is making an alpha, right? It is making an angle alpha with the north, or it is making an angle alpha with the upward vertical towards east, right? So I think according to our problem it is 60 degrees, right? Velocity of the opposition boat with respect to the combat ship is making an angle alpha, that means 60 degrees with north. And what is the value of that? That is 10 kilometers per hour, right? So now that is the scenario, right? So now how to find that? So now here it is not just like adding at one side, right? So here you cannot directly add, right? Because now the reason is here we have to consider components, right? We have to consider components, right? Because if both the velocities are towards one particular direction, for example, let's say this is also towards upward direction, then we can very easily add, right? But the scenario is not like that, right? Here the directions are different. So that means we have to consider components, right? So here we have 10 kilometers per hour making an angle 60 degrees with the upward vertical. That means this part we can write in components. So how to write it like that? Here we have 60. That means towards upward direction we have 10 cos 60, right? 10 cos 60. So let's put some dotted line. What is this one? 10 cos 60. So what is this one? 10 sin 60, right? So now again I will shift to this side. So what do you have? We have 10 cos 60 towards upward direction, right? Plus 10 sin 60 towards 10 sin 60 towards horizontal direction, like that. And again we have 20, right? 20. Now this 20 is from the combat ship, right? So now we can separately add vertical components and horizontal components. So here we have 10 cos 60, right? So what is cos 60, right? Cos 60 is half, right? So 10 multiplied by cos 60 is half, so that means 5, right? And what is this one? That is 20, right? Then 10 sin 60, right? What is sin 60? 10 multiplied by sin 60. What is sin 60? That is root 3 by 2, right? Then if you simplify, 2 times 1, 2 times 5. So answer will be 5 root 3. So what is the ultimate answer? What is the ultimate vertical component? 5 plus 20, that means 25. What is the ultimate horizontal component? Going there, 5 root 3. So but now here you have to combine both of these components, and you have to keep one total answer, right? Right. So here we have 25 and here we have 5 root 3. Okay. So now how to keep the ultimate answer? Okay, right. So now what is the ultimate vertical component? That is 25 kilometers per hour. Right? And what is the ultimate horizontal component towards here? That is 5 root 3 kilometers per hour. Right. So now we have to find the resultant. right? The total. So let's say the resultant is this one, right? That means the ultimate force where we can replace both the vertical and horizontal components. So let's say that is R, right? So you know how to calculate R, right? R equals square root 25 whole thing squared plus 5 root 3 whole thing squared. 25 whole thing squared 625 plus 5 squared 25. 25 into root 3 squared. Root 3 squared is 3. So 25 into 3, that is 75. 625 75 is 700, right? So what is square root of 700? It is 10 root 7. Square root of 700 means 10 root 7 kilometers per hour, right? So now you know what is the resultant, right? Right. So the resultant force you know, right? So this is 10 root 7 kilometers per hour. And you need another thing. What is that? That is the particular angle, right? So you need to find the angle that it makes with some considered reference, right? So I think, as you can remember, even for the previous case also, right, when we were evaluating the velocity of the opposition boat with respect to the combat ship also, we considered some reference line. So what is the reference line? The upward vertical, that means the north, right? So we measured the angle with respect to the upward vertical or the north, right? So here also we can consider some angle. I think there it was alpha. Now here it will be, let's say, theta, because we need some particular angle, right? So what is this angle theta? So theta, you know, now we can form a trigonometric relationship, right? So you know what is theta. So theta will be, if you consider tan theta, what is tan theta? Tan theta equals, if this is theta, tan theta will be this component divided by this component, right? Tan theta equals 5 root 3 divided by 25. 5 into 5. Then tan theta equals root 3 divided by 5. So then what is theta? So then what is theta? Theta equals tan inverse root 3 divided by 5, right? So then now we know the final answer, right? So let's write it here, right? I will erase this part, right? So then, okay, so now we will write the ultimate answer. The velocity of the opposition, boat is 10 root 7 kilometers per hour, making an angle of tan inverse root 3 divided by 5, right? With the north towards east, right? Because we have to, like, if you are going to specify the angle, we have to say it like making an angle theta with the north towards where, right? Towards east side or towards west side, you have to specify. That means with the north towards east, right? Because you know that this side is east, right? So this is the answer, right? So that's all about the relative velocity type problem, right?